Hello, welcome back to the Basics of Diag YouTube channel. Today we are looking at a 2012 Vauxhall Astra with the 2-litre CDTI engine in it. The vehicle owner's concern is lack of power. Feels like it's in limp mode, and a service vehicle soon message has come up on the dash. We've got no engine management light, but yeah, just a lack of power. I have already confirmed the fault, and yeah, I can confirm it is very underpowered. So the next step is going to be plug the scan tool in, see if we've got any codes to point us in a particular direction. So here we are, I've just done an auto ID, and we're just going to go in through, do I do a full code scan? Go on then. And there we are, 9 codes in engine management. Now, in all fairness, I did scan this the other day, and this P0048 code, along with this lost communication with cruise control module, they were the only 2 codes present. Obviously, I have had this boost solenoid unplugged. Oil pressure sensor fault, I've just started it up now, and low oil pressure warning come on the dash. It's a common issue on these. The oil pickup pipe is sort of cast as part of the sump, and there's a rubber seal that's sandwiched between the sump and the sort of bottom of the oil pump in the bottom of the block. Them seals go brittle or less flexible, and this problem is more noticeable in temperatures close to freezing, which we are now, 3 degrees. Once the oil's warmed up, it isn't a problem. It's just that initial startup where we have an issue. I'm not bothered about that. EGR cooler bypass solenoid valve. Don't know why that's there. That wasn't there before. I'm going to ignore it for now. This vehicle doesn't do much mileage. The DPF light came on when I was looking. Obviously, I had it idling to do my tests. When I'd come back in, the DPF full warning was on the dash. So I'm going to put a cleaner in there. Obviously, if these other faults come back, it'll be another video. For now, we're just focusing on that P0048 turbo boost control solenoid, circuit high. Now we can look at some data. I think the data on this is actually not that great. Let's just have a look. So we're in here now, and I don't think there is much data available for like the turbo. Obviously, we've got boost pressure we could look at, but we know it's probably not going to be giving us any boost pressure. I don't think there was anything for like boost control solenoid sort of activation or percentage, so we can't see what the ECU is demanding from the boost control valve, so I'm not even going to bother looking at data, I don't think. What we might be able to do is go into the functional tests and see whether there is an option to activate the boost control valve. So I'll do that now. So we'll go in actuator tests, cooling fan, EGR, fuel pump, turbo vane position, that'll be it. So The only problem is, obviously, during activation, ideally we should be hooked up into both sides of the boost solenoid, you know, with a scope, seeing what is happening on each wire. At the minute, all we can do is see whether that vane position moves, the wastegate, or what you would call the wastegate actuator moves, but it doesn't tell us anything we don't already know, really. So obviously my oscilloscope is built into this scanner, so I can't do this active test and measure voltage at the same time. So I think we'll just skip that, and we'll start off by looking at the wiring diagram. Now, it is just a 2-wire solenoid, as most solenoids are. They only need power and a ground to operate. On this solenoid we have a permanent power, which is fed by a 10 amp fuse from the underhood fuse box. The ground is controlled by the ECU, so depending on where it wants the turbo position will depend on how long that is pulled to ground for. So we'll probably start by scoping it and seeing whether we've got ground and a permanent supply. Let's do that. Right then, so I am in both sides now on this boost control valve, and what I've got is battery voltage on both sides. I've just moved green channel down a bit so we can see both lines. But yeah, you know, that shouldn't be the case. So I'm going to unplug it. Now we get green channel, which stays at battery voltage, so we know that is our feed. I'm going to get a test light now, just to load the circuit, and see if this voltage stays where it should be. Right then, I've got this cheap little test light. It's quite good. It's got an LED display. There's 3 modes you can use. We've got a voltage display in there with LED. I can press the button. There's a 501 bulb in the top. Press the button again. It'll show us the voltage along with the load turned on. So we just need to load this green channel on here. It might be off. One-handed. So bulb comes on, voltage says 14.8, voltage on the scope says 14.6, so the power supply is good. Obviously we're load testing it because this solenoid valve isn't working, so this isn't under load at the minute. I don't know if this isn't working. I don't know if the ECU isn't controlling it. I don't know if the earth wire is broken. So the next step is to get a power probe and try and take control of this valve and see whether we can get this actuator arm to move. Right, power probe now. We're hooked up to the battery. I've got some breakout leads on this solenoid valve. I've got my ground hooked up to the ground side, which is the yellow side. Green channel, as we know, is power supply. There's a mode on this I can select where I can measure the current flow through this valve. Hard to do one-handed, bear with me. So we've got 1.6 amps of current flow. You can see this actuator arm is moving. So we know all the vacuum lines are good. We've got vacuum up to this, otherwise it wouldn't move. So that leaves the ground wire or the ECU as a potential fault. Right, what I've done now is I've just sort of this loom only goes from here to here. This is our ground, or what should be our switched ground. We're still hooked up. Green channel is still in here. Yellow channel here. It's obviously, yeah, the same like it was. I'm just gonna probe this as close to the ECU as I can go. I know you shouldn't really be piercing wires, but the next thing is kind of strip this plug down and sort of back probe in here if we can. It's obviously pin 73, which is this bottom connector. This top one only has 62 pins. Unless I can get in, it's this. Yeah, I can't really, without stripping the plug down, get in properly. But if I sort of probe it here, just pierce the wire. And then take a look at this. It's still reading battery voltage. The next thing that I'm going to do is load test the wire. I'm going to unplug it here, unplug it in the ECU, use my test light to apply a load. Now, got this wire isolated now at both ends. Green probe is in the black and white side. That's connected to battery negative. This is in pin 73, which should be the other end of this wire. I've got my test light on battery positive. If I put it on battery negative, we light up with 12.6 volts. If I pop it in here, we light up with 12.5 volts. So the wiring is good. So we know both wires are decent. We know that our power supply can handle a load. Yeah, the earth can handle a load. We know that the component itself can operate. It was drawing 1.5 amps, which, to be honest, to me, was 1.6 amps is a bit high. Usually, I would expect about 0.8 of an amp, you know, 0.9 of an amp maximum. So I'm gonna resistance check that solenoid. I know resistance measurements are a bit sort of frowned upon, I would think. But I know from looking at a few of these solenoids across various models that we should be seeing 15 or 16 ohms. Obviously, before I condemn the control unit, I want to be certain it's going to fix it. So that resistance reading just gives us another sort of layer of information, another piece to the puzzle. We could be sort of short-circuited inside there, which is why the resistance may be lower, the current is higher. If the control unit knows that, it may not allow it to operate because the excess current could damage components internally, control units internally. So I'm going to do the resistance check, and then I might substitute that solenoid for something of a similar ohm rating and see if I can fool the computer into turning on and obviously switching that ground on and off. So let's do the resistance. And right, so again we're just on breakout leads off this valve. I'm plugged into the ohm side with my yellow black channel. I'm on 40 ohm scale, and I just need to plug this into here. And what do we get? We get less than an ohm, 0.21 of an ohm, which is too low in my opinion. So what I'm going to do, find a component that's got a similar resistance reading as this and wire it in using these. Get the scope on and see whether that ECU starts switching. Right then, what I've got now, I have bridged. I haven't, have I? Not yet. I'm gonna bypass this with a washer pump. It's got 21 ohms of resistance. It's a little bit high, but I'm not too bothered. I've got a video on my channel called Ohm's Law for mechanics or technicians. Basically we just go through a load of old components off vehicles using that power probe, looking at the voltage, the current draw and resistance, and obviously seeing the difference between each component. We try and keep voltage the same, and then as the component changes or resistance changes, we see how that affects current flow. So I've just been back on that just to see what component I had lying around that would have a similar ohmic rating as what that solenoid should have. Turns out it's a washer pump. So we're going to use the breakout leads to wire that washer pump into the boost solenoid harness, and hopefully the ECU likes it and then starts switching it on and off. So let's see what happens. Right, my washer pump trick didn't work. Yeah, no activation from ECU. We had the same results as with the solenoid plugged in. Got me wondering whether it's monitoring turbo position as well, and if it's not happy with where the turbo position is, then it's not going to obviously switch this on and off. So I tried moving the turbo, obviously activating the solenoid using my power probe. Still didn't get any activity on the washer pump side of things. When I was using this, I noticed the solenoid started making a bit of a weird vibrating type of noise. Plugged the solenoid back in, and we got some activity. This is obviously the ground side. It's at, what's it at there? 3 volts or so, 3.5 volts. That must be some sort of bias voltage or diagnostic voltage it's sending out. But if we move along, obviously this is where I've plugged the solenoid back in. We get a bit of fuzziness going on, and then look, we get some, how do I zoom in? There we are. So, plugged it in here, and then we get all this activity as the solenoid starts working, and then yeah, it stops working again. So for me, And that's where I've taken the wire out, or I've unplugged the solenoid and plugged it back in. For me, it's going to be a case of replacing that solenoid now. That was a bit of a tricky one to find, to be honest. I suppose it just goes to show, just because this power probe can activate it, we saw it, it moved it, we got the turbo to move, doesn't mean the solenoid is any good. Had I heard the weird noises it was making at the start, I probably would have looked more closely at it, but you just sort of test it, see it's moving, and then sort of move on, don't you? But yeah, I'm gonna order a new one, and then would compare the resistance of a new one to the old one. We'll look at both signals on obviously the ground side, the supply side, with the new one plugged in, and then yeah, that'll be this video done. Right, it's a couple of days later now. It's not really, it's a couple of weeks later now, and we've got the new boost control solenoid fitted. I got a Peerberg item from my local motor factors. I was looking on eBay trying to get a matching part number, but you know, if it's wrong, it's harder to send back on eBay. At least with a local motor factor, I can open the box, see it's wrong, or try and fit it and it be wrong, take it back and either get a refund or get the correct item. So that's what we've done. The code has cleared, and now probably the most important step is to check the circuits now that the part works. You know, power, grounds, we can recheck the current draw with my power probe, check the resistance of that solenoid, just the next time we get one, we're not going to be wasting as much time, I guess. Yeah, so let's have a look at the scope first. So both channels again, I think yellow channel is the power supply, green channel is the switched ground. Obviously at the minute I'm ignition off, so I'm going to turn ignition on now, and straight away we get obviously power, and we had a bit of control there. Now I'm going to go for a crank, and there we go. Obviously you get a bit of voltage drop because of the amount of current that the starter motor is drawing. You can see if I just snap the throttle a bit, you can see the pulse widths, they're changing. I reckon if I go on to, I'm just going to come out of this. This probably isn't relevant at the minute for obviously fault finding this. If I go onto this graphing multimeter, go on to frequency, I may need to swap green and yellow channels around. This might be more visible when driving. Obviously this is now graphing that pulse width square wave signal as a frequency. Obviously the frequency at the minute is 305 hertz, or 305 times a second, and obviously as boost is demanded, this should change, go up, down. I'm not sure which way it's going to go. Yeah, that's just a bit of that. That is handy when you're graphing, when you're looking at airflow meter signals. graph it as a frequency, you can see sort of dropouts and any odd weird peaks that shouldn't be there. So there is a working non-good boost solenoid, power supply, switched ground with ignition off, ignition on and engine running. Now I'm going to use the breakout leads again. We're going to measure resistance of this new solenoid. If we remember, the old one was less than an ohm. Right, for some reason the ohm meter on this is packed in. So we're going to take a look at the resistance of that new solenoid on this. I'm just going to plug these two banana leads into the top of this. And what are we going to get? About 15.5 ohms, which I'm pretty sure is what I said earlier on. Yeah, and now power probe. Obviously, last time around, did we have about 1.5 amps of current flow, which I thought was a bit high. So we're going to hook up to the battery, do the same test and see what current flow we get with the new solenoid. Right, we're in. We've got the green light. Change mode. Obviously you can see this is saying, yeah, about 15 ohms as well. So you saw there we had 0.86 of an amp of current flow, and we know there was about 15.5 ohms of resistance. If we do a bit of Ohm's law, we can do, what can we do? It'll be current times resistance, and we should get the battery voltage that we were applying to that solenoid, which should be about 12 volts. So it'll be 0.86 times 15-ish ohms of resistance. Don't know what that is. Sounds like it's around about 12 volts. I'm just going to work it out on my calculator. Yeah, so 0.86 times 15 ohms is 12.9 volts. Times 14 ohms is 12.04 volts. So it's round about the ballpark, isn't it? So that's good. What I'm going to do now is I'm going to try the washer pump again, you know, the bypass test. When I connected the new solenoid, it didn't work straight away. I had to clear the cords. So I'm wondering if I had cleared the cords earlier on in this video, whilst that washer pump was plugged in, you know, with breakout leads, I'm wondering whether it would have started working. So let's try it. Wasn't ready for this. It's working. As soon as I opened the driver's door, that washer pump's fucking working. I don't know why I'm so excited by that. Oh, I haven't even cleared the cords. Maybe there isn't any yet. I don't know. Oh, sorry, I need to compose myself. Right, so obviously there must be some sort of overcurrent protection within the engine control unit. It wasn't happy with the original boost solenoid that was, you know, less than an ohm of resistance. Obviously this washer pump, if we remember from last time, was about 21 ohms, which, you know, more resistance means less current flow, so there isn't going to be an overcurrent situation. That's fucking mental. But to be fair, all that's controlling that solenoid is a power and a ground. All that controls this, a power and a ground. So really, it makes sense, doesn't it? The only thing that would stop it is if it wasn't happy with the turbo position, you know, when it's trying to operate this, thinking it's operating the boost solenoid, it's expecting to see that turbo actuator move, and obviously the position sensor won't move, but that is a good test of wiring. If it can operate this, obviously the earth's good, power supply's good. It'd have been interesting to scope it and see what it was trying to do. There's one other thing I tried earlier on, and that was trying to activate the boost solenoid with my scanner whilst scoping. However, my scope is built into my scanner and couldn't do it. But I recently bought this Topdon Top Scan for £45. It's just a Bluetooth dongle. It's plugged in at the minute. There's an app on the phone. I'm going to plug the old boost control solenoid in. Then I'm going to try and activate the solenoid and see whether we get the square wave control from the ECU. If we do, that's something I probably should have done right at the start. It would have confirmed that the ECU could control the solenoid, would have confirmed the power supply, possibly, unless it's not happy with, like I say, the extremely low resistance of that old thing. I'm going to plug it in and see what happens. This is the old solenoid, plugged back in. Unfortunately, the app for this little Bluetooth dongle is built into my phone, which is also what I'm using to record with. So there may be a bit of still screen at the minute, but I'm going to screen record the scanner. We'll go in now and see if that P0048 code is back. Okay, so I'm already logged in to Vauxhall. Automatic selection, ignition is on. Confirm VIN, yeah, Astra J. Just want control unit, engine, not equipped with stop start, DTCs, display DTCs, glow plug fault. So we have no boost control fault. But if I start it for a bit, we've got no boost fault even with that old solenoid now plugged in. I'm looking at the scanner, the scope. I've got both channels scoped. It's power supply and we've got the switched earth. I don't know whether, because I've had this old one on, off, and I've been, rattling it around. It's been rolling around the floor of my car for a week or so. It is now obviously operating as it should, which is not ideal for this video. Yeah. Still no turbo fault, so this test that I'm trying to do is going to be pointless, really. What we're going to do is go to control functions, turbocharger, vane position, and then we can increase the position whilst looking at the square wave command on the scope. We should see, as we increase the command, we're going from 0% up to, well, I don't know what we're going to go up to, 100% maybe. We should see the command change, and it has. The vane position is at 94%. I don't think that can get any further. Well, it can, 96%. But loose. So once, yeah, obviously there's vane position command, and then there's vane position solenoid. Vane position solenoid gets to 96% and then it's maxed out. So once we start dropping from 50%, 45%, the square wave starts to noticeably change. But this isn't really valid because that old solenoid seems to be working now as it should. We don't have the fault code. I'll double check again. Yeah, well, yeah, boost control position not learned. That's probably because I've been operating the old solenoid whilst not connected into the vacuum system. So yeah, that's that. Right, so what I was trying to achieve with that activation test was seeing whether when activated through the scan tool, the ECU could command the boost solenoid to change its position. Now, it's probably an invalid test because it seems to be working as it should. Obviously, I didn't have this Bluetooth, this top-down scanner when I originally started this video. It's part of the reason that I bought it, and it was cheap. So yeah, but next time, you know, I'll be able to get this scanner on, get my scope hooked up, and do the same test whilst the fault is present. And if we see the ECU try and command that ground to, you know, switch, do the square wave job, then we know the ECU can control it. Wiring must be good. Obviously we have the power supply, so it's got to be the component itself, the boost solenoid, that is at fault. As it happened, I couldn't do it, so I had to, you know, use other methods. The test light, the power probe, which gave us a bit of a false reading, to be fair. Well, it didn't. We knew it was pulling too much current, but the valve still moved, the turbo still moved. Yeah, obviously we got there in the end. That's the main thing. We got there in the end, and did we learn something? I think we did. So that's the end of this video. We'll see you in the next one, which is going to be a glow plug fault, because there's a glow plug fault on this Astra. You may have seen the code. Anyway, see you in the next one.